So that oblique planes, in that oblique plane, we have to calculate what is the stress acting. So first we shall see what is principal plane. These are the planes which have no shear stress, and only the normal stresses will be acting on this plane. So these planes are called as principal planes. So principal planes, once again I am repeating, it is a plane in which there is no shear stress, and these planes only carry the normal stresses. So such planes are called as principal planes. Next is principal stresses. The stresses acting on the principal plane are known as principal stresses. You consider a body like this. L, M, N, O. You consider a rectangular body like this, in which force P is acting. So whenever you calculate the stress, we know that stress is given by force by area. So where the stress will be acting? So this stress will be acting in this plane. You consider a plane EF which is perpendicular to the direction of the applied force. So the normal stress acting on the plane EF is given by P by area. Now you consider any other plane which is at an angle theta to the plane EF. So you are considering the plane FG. So this FG is inclined at an angle theta to the plane EF. Now if you have to calculate the normal stress and tangential stress along this plane, that is the plane FG, how it can be calculated? So this is your normal stress and this is your tangential stress acting along the plane FG. So how this can be calculated? So sigma n, it is the normal stress across FG, and sigma t, it is the tangential stress across the plane FG. So this is your plane FG. So the yellow colored highlighted line is the plane FG, which is inclined at an angle theta to the plane EF. So in the plane FG, I have to calculate what is the normal stress and what is the tangential stress. We know that stress is equal to force by area. So this is applicable if the plane is perpendicular to the direction of the applied force. But here the plane FG is not perpendicular to the direction of applied force. So I have to calculate the values. So this value sigma n and sigma t can be calculated by resolving the forces parallel and perpendicular to the plane FG. So I'm not deriving the whole equation, I'm just writing down the final result. So if you resolve the forces parallel and perpendicular to the plane FG, I will be getting the normal stress across FG and the tangential stress across FG. So sigma n is given by sigma cos square theta. So what is this sigma? This sigma is equal to P by A. And what is this theta? The theta is the angle between the normal plane and the inclined plane FG into 2 theta. So in this equation, when will be the value of sigma n be maximum? So this value will be maximum when cos square theta becomes 1. So this cos square theta is equal to 1. This you can get when the value of theta is 0. So if you put theta is equal to 0, cos theta will be 1 and cos square theta will be 1. So if you put theta is equal to 0, I will be getting the maximum stress. Similarly, the maximum tangential stress, sigma t, this you can get when this value sine 2 theta is equal to 1. So if sine 2 theta is equal to 1, we know that sine 2 theta is equal to 1 when the value is 90 degree. So instead of 2 theta, you have to put 90 degree. So 2 theta is equal to 90 degree, or you can say theta is equal to 45 degree. So the maximum tangential stress you can get when the value of theta is 45 degree or 135 degree. So from the definition, what is principal plane? It is a plane which have no shear stress. So if in the given figure, if I have to find the maximum, that is the principal stress, I have to put this value. Tangential stress is equal to 0 and find what is the value of theta. Because in the principal plane, the value of tangential or shear stress will be 0. So you can equate sigma t is equal to 0 and find the value theta. So the theta will give the angle of the principal plane. So this is your first category, and in this sum only the direct stresses are acting. In only one direction the stresses are acting. So this is a single direction P, and this both are the direct stresses. Now the second case is a member is subjected to like direct stress in member is subjected to like direct stresses in two mutually perpendicular directions. So consider a body A, B, C, D. You are having a body A, B, C, D. So in this body A, B, C, D, in this body A, B, C, D, two stresses are acting. One is sigma 1 and the second one is sigma 2. So sigma 1 is in the x direction and sigma 2 is in the y direction. So I am having direct stresses in two mutually perpendicular directions. So in this case, no shear stresses are acting. In this body, consider a plane FC or CF, which is inclined at an angle theta to the plane side BC. So in this plane FC, what is the normal stress and what is the tangential stress? So that you have to calculate. So sigma n is the normal stress across the section FC, and sigma t is the tangential stress along the section FC. So CF in the CF plane, I have to calculate the tangential stress and the normal stress. So sigma n. So when you resolve the forces perpendicular to the plane FC, you will be getting the normal stress. So the normal stress is equal to sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 into cos 2 theta. So this is the value of normal stress across the section FC. Next is the tangential stress. The tangential stress is given by sigma 1 minus sigma 2 divided by 2 into sine 2 theta. So when you can get this value of maximum shear stress, so this tangential stress will be maximum when sine 2 theta becomes 1. So sine 2 theta is equal to 1 when you have the value of theta or 2 theta is equal to 90 degree or 270 degree. You can say theta is equal to 45 degree or 135 degree. So these are the values of normal stress and tangential stress. So here I am having a normal stress. Let me show in a separate page. So if you are having a body like this, we know that stress is equal to force by area. So this stress will be acting in a normal plane x x. So this x x is perpendicular to the direction of the applied force P. But in practical cases, we may have to find the stresses which are acting in this direction or any other direction which is inclined at an angle theta. So you can have the normal stress like this and the tangential stress like this for an oblique plane. So this tangential stress and the normal stress I have to calculate for different cases. So that have been calculated in the previous cases. So the tangential stress is given by sigma 1 minus sigma 2 divided by 2 into sine 2 theta. Now I am having the normal stress in this direction. So this is the normal stress and this is your tangential stress. The resultant of this two stresses will be your resultant stress sigma r. The angle between the normal stress and the resultant stress is called as the angle of obliquity. So you can say it as obliquity or angle of obliquity. So this angle is the angle between the resultant stress and the normal stress to the oblique plane. So I can write tan pi is equal to opposite by adjacent. Opposite is sigma t and adjacent side is the normal stress. So tan pi is equal to sigma t by sigma n. So how you can find the principal plane? So the principal plane is the plane in which the shear stress or tangential stress is equal to 0. So on the previous page we have calculated what is sigma t. That is tangential stress. It is equal to sigma 1 minus sigma 2 divided by 2 into sine 2 theta. So now I have to equate this value to 0 to get the principal plane. So whenever you are asked to find the principal plane, what you have to do is you have to equate the tangential stress to 0 and then you have to calculate the value of theta. So sine 2 theta is equal to, so in this step, you have to equate tangential stress is equal to 0. The value of sigma 1, sigma 2 can't be 0. So the only possibility is sine 2 theta may become 0. So when sine 2 theta is equal to 0, I can say theta is equal to, sorry, this 2 theta is equal to 0 degree or 180 degree. So if 2 theta is equal to 0 or 180 degree, what is the value of theta? So 0 by 2, 0 and 180 by 2, 90 degree. So when theta is equal to 0 and when theta is equal to 90 degree, you will be getting the principal plane. Substitute theta is equal to 0. If there is a body like this, normal stress will be acting and tangential stress will be acting. You have to equate sigma t is equal to 0 and find what is the value of theta. So that value is the inclination of the principal plane. So using the value of theta, I have found what is the principal plane. Now I have to find what is the normal stress acting on this principal plane. So previously I have calculated what is the normal stress. So this is your normal stress. So this equation. This equation 1 is the normal stress. You note down this value. So normal stress is equal to sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 into cos 2 theta. Now put the value of theta is equal to 0. So if theta is equal to 0, cos 2 theta will be 1. So finally I will be getting sigma 1 plus, you divide this and write sigma 1 by 2 plus sigma 2 by 2 plus sigma 1 by 2 minus sigma 2 by 2. So this value becomes 1. Now plus sigma 2 by 2 and minus sigma 2 by 2 gets cancelled and remaining will be having sigma 1 by 2 plus sigma 1 by 2. So that is equal to sigma 1. So the normal stress is equal to sigma 1. Now we have to find the normal stress when the angle is 90 degree. Sorry, the principal stress. So this is your principal stress. So when theta is equal to 90 degree, I will be getting cos 2 theta as cos 180 degree. Cos 180 degree is minus 1. So this value becomes minus 1. So I have split this sigma 1 plus sigma 2 by 2 as sigma 1 by 2 plus sigma 2 by 2. Here I will be getting minus 1. So minus 1 into plus sigma 1 by 2 is minus sigma 1 by 2, and this is minus into minus, I'll be getting plus sigma 2 by 2. So here sigma 1 by 2 and minus sigma 1 by 2 gets cancelled. Remaining will be having sigma 2 by 2 plus sigma 2 by 2. So I'll be getting sigma 2. So this is the normal stress or the principal stress, or you can say it as a principal stress. I think this equation has been derived in the previous class. You are having a body like this. In this body, if only shear stresses are acting, in this plane Cx. So in the plane Cx, I'll be having a normal stress and a tangential stress like this. So the value of the normal stress and the tangential stress has been derived in the previous classes. So normal stress is equal to tau sine 2 theta and tangential stress is equal to minus tau cos 2 theta. So the next case is you are having a body So what are the cases we have seen? A body in which direct stress is acting in only one direction. For this case, we have found what is normal stress and what is the tangential stress, and then forces in two direction. For this case, we have found what is the normal stress and what is tangential stress. The third case, shear stress is acting on the body. For this case also, we have found what is the normal stress and what is the tangential stress. The fourth case is I'm having a body like this in which the normal stresses are acting in two perpendicular direction and also shear stress is acting. So this will be a combination of this and this. So for this case, I have to calculate what is the normal stress and what is the tangential stress. The normal stress is equal to sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 into cos 2 theta plus tau sine 2 theta. So how you get these values? So tau sine 2 theta is the value due to the shear stress acting on the body, and this within the bracket. So this is due to the perpendicular uh, stresses. So two direct stresses in two directions are acting, sigma 1 in one direction and sigma 2 in the other direction. So due to this, we'll be having, see, we are having four cases. First one is stresses in a single direction or single plane. Second one, stresses in two perpendicular planes, and third one, shear stress along the planes. Now the fourth one is combination of this one, direct stresses in two mutually perpendicular direction and shear stress in the other planes. So for this, all the cases we know what is sigma n, sigma t, sigma n, sigma t. So this value tau sine 2 theta is the value of normal stress only when the shear stress are acting. Only when shear is acting, and this value within the brackets is the value of the normal stress when the stresses are acting in two mutually perpendicular directions. Since our case is a combination of both the cases, I have to sum these two terms. Now the tangential stress in the plane FC. So what is this value and what is this value? So this value is the tangential stress when the stresses are acting in perpendicular directions. And this tau cos 2 theta, it is the tangential stress when the shear stresses are acting alone. So I have to sum it. So if I sum, I'm having minus. So can anyone say how the minus came? Because in the equation sigma t, so this one, sigma t, you have found to be minus tau cos 2 theta. So actual formula will be plus so plus into minus tau cos 2 theta. So plus into minus minus. So that's why I have directly written as minus. So this is one of the oblique plane FC. Here you will be having the tangential stress and normal stress, but in the principal plane, only the normal stress will be acting and there will be no tangential stress. So how you can find the value of that particular plane and the angle theta? So for that, I have to take sigma t tangential stress is equal to 0. So you take down this value and equate this to 0. I know sigma 1 minus sigma 2. So this tangential stress is given by sigma 1 minus sigma 2 by 2 into sine 2 theta minus tau cos 2 theta. So this is equal to a tangential stress and this is equal to 0. So why you are putting 0? You have to put sigma 2 is equal to 0 to find the location of principal plane. So sigma 1 minus sigma 2 by 2 into sine 2 theta, you bring this minus on the right hand side, it will become plus. So you'll have tau cos 2 theta. In the next step, you bring this cos 2 theta in the denominator. So I'll be having sine 2 theta by cos 2 theta is equal to tau divided by sigma 1 minus sigma 2 divided by 2. So sine 2 theta by cos 2 theta is equal to tan 2 theta. So tan 2 theta is equal to bring this 2 in the numerator. So I'll be having 2 tau into 2 tau divided by sigma 1 minus sigma 2. So if you draw a right angle triangle like this with 2 theta as the angle. So this is your angle 2 theta. We know that tan theta is equal to opposite by adjacent in a right angle triangle. So assume this right angle triangle. In this triangle, we got 2 tan theta is equal to 2 tau divided by sigma 1 minus sigma 2. So now this is your opposite side and this is your adjacent side. So 2 tau, you put this 2 tau opposite to this angle. So this is your opposite side and this is the length adjacent to the angle 2 theta. So this is your adjacent side, sigma 1 minus sigma 2. So from this triangle, you can find what is sine 2 theta and cos 2 theta. Sine 2 theta, what is the formula for sine theta in general? Opposite by hypotenuse. So in this triangle, what is the opposite? 2 tau is the opposite. So sine 2 theta is equal to opposite. And what is the hypotenuse? So hypotenuse is equal to the square root of the opposite square plus adjacent square. So what is your opposite side? The opposite is 2 tau. When you square this, you'll be getting 4 tau square, and when you square the adjacent, you'll be getting sigma 1 minus sigma 2 the whole square. So both these values will be within the square root. Similarly, you can find what is cos 2 theta. Cos 2 theta is equal to adjacent by, so this value is equal to adjacent by hypotenuse. So what is the adjacent? Sigma 1 minus sigma 2. So that I have written in the numerator. And what is the denominator? Hypotenuse. So what is the formula for a hypotenuse? It is the square of opposite and the adjacent. So what is opposite? It is 2 tau. When you square this, you will be getting 4 tau square. And what is adjacent? sigma 1 minus sigma 2. So that is your adjacent. When you square, you will be getting sigma 1 minus sigma 2 the whole square. So both these terms will be within the square root. So you have found what is the value of cos 2 theta and what is the value of sin 2 theta. If you substitute these values here, you will be getting the maximum and minor principal stress. So you will be having two values for theta, not a single value. Two values will be there. So if you substitute one value, you will be getting the maximum principal stress. And if you substitute the other value, you will be getting the minor principal stress.